Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in the subject short range wireless communication. We're going to see RFID technology. RFID means radio frequency identification technology. In short range wireless communication, so far we have seen a lot of short range technologies. We have seen what is UWB, we have seen Bluetooth, we have seen Wi-Fi, we have seen a lot of technologies in previous videos, and this is going to be another interesting topic, which is RFID technology. First, I would like to set up a clear expectation about this particular technology. I'll tell you about the working, what are the different criteria in this RFID technology before going in depth about it. Right. To start with, RFID, as I said, it is a radio frequency identification technology, and this is very similar to the barcode technology which we have seen in daily life. Right, the barcode technology. The only difference between the barcode and RFID technology is barcode technology works with line of sight communication, right, where the reader and the tag has to be in line of sight. Only with line of sight this will work, but the RFID has the advantage that it can cover a certain area, so that if the tag is in the zone of this reader or in the coverage area of the reader, then it will work. It will work beyond the line of sight as well, right? So that is the greatest advantage of RFID technology. And coming to this RFID technology, how it works, we can say this as an interrogator transponder technology, right? It works like an interrogator transponder, right? It cannot be called as a communication technology, like where it will communicate, like it will involve transfer of data, but more than saying a communication devices, we can say it will act as an interrogator transponder. What is interrogator transponder? I repeat that, it is an interrogator transponder. Interrogator transponder. What does it mean? So we already know what is transmitter and what is receiver, and right now you have to understand what is transponder, right? So transmitter is something where it will transmit a signal, right? It will generate the signal, it will transmit it, and receiver where it will receive the transmitted signal, right? That is the operation of a receiver. Whereas transponder performs both the operation, that is, it will transmit and as well as it will receive, right? And here, to be very specific, transponder, it will receive a signal, right? It will receive a signal, and in response to that particular signal, it will transmit a different signal. That is the exact working of a transponder, right? And what is interrogator? An interrogator, like it will get that whenever it receives a signal, it will get activated, right? And then it will transmit the signal. That is an interrogator. So RFID here, it will work as an interrogator transponder. That's what I say. And when we say RFID, we need two important components. One is RFID reader, another one is RFID tag, right? And this RFID reader is the one which is going to send the signal, right? And this signal will be sent to the tag, and the tag will receive that signal, and it will reflect another signal, right? That is, it will act as a transponder. And after receiving this signal, which is reflected from the tag, that signal will be sent to the host application, right? This is the normal working of RFID technology. We have a reader. The reader will transmit a signal, right? And that transmitted signal will enable this RFID tag, right? It will activate the RFID tag, so that the RFID tag will respond to that particular signal with a different signal, and that different signal will be received by the RFID reader, and it will be sent to the host application, right? So this is the normal working. But when it comes to application of RFID, we have a lot of application. It is used in almost all fields right now, right? Whereas it is used in logistics, we have used in hospitals, right? Even in toll gates, you have a lot of applications. You can see it is almost used in all fields. Even in shopping we use, even in robot industry, logistics, right? Surveillance and healthcare. We use RFID in in almost all fields right now, right? And as I said, when we come to RFID, this tag and reader plays a very important role, right? And this tag, when come to this particular tag, this tag is the one where you'll have the information, right? The tag, you'll have a coded information. So any particular device, that is, if you want to monitor any particular device, right? If you want to track any particular device, we can have this tag on that particular device so that we can able to get the information frequently from that particular device, right? A very good example here is your normal toll gate operation. Whenever you travel through car, right? You know that whenever you cross the toll gate, right? You'll have a gate like system where it will be locked until it reads the information from the car tag, and once it reads that information, the gate will automatically open, right? So that is a very good example of a real-time application of RFID, right? And when it comes to this particular tag, the car itself will have the tag, right? The tag information, that is the car number, the name of the owner, whatever may be, right? The tag will contain the particular information about the car, right? The number, the registration number of the car, right? And that particular tag will be activated by the reader which is present in this particular gate, right? In the toll gate. So once it receives that particular signal, right, the tag will get activated, and then the tagged information will be sent as a response to that particular signal, and the reader will receive that particular signal and it will be sent to the host application. This is how the toll gate works, correct? And apart from it, you got to understand when it comes to these tags, right? These tags can be of different types. We have active tag, we have passive tag, we have semi-passive tag. Semi-passive tag. What does it mean? Active tag, where the tag, now you understand what is tag and what is reader, right? So whatever device which we need to track, right, that information, it will be stored in that particular tag, and the tag will be placed in that particular device, correct? So this tag can be an active, passive or semi-passive. Active in the sense, the tag itself will have its own powering system. It will not depend upon the reader. It will have its own battery device, or it will have its own source of power, right? That is active tag. When it is passive tag does not have any source of power. It will get activated based upon the signal which is received from the reader, right? The reader signal will activate the passive tag, and with that particular power, it will transmit the signal, right? So receiving and transmission both will be done based upon the reader's signal. It will get powered from the reader's signal. That is passive tag. What is semi-passive tag? Semi-passive tag is in between the active and passive tag, where semi-passive tag is also having a powering system where you have a battery, inbuilt battery with that, but it will help only to receive the signal from the reader, right? But in order to transmit the signal, once again the passive tag has to depend upon the signal which is received from the reader, right? So that is the difference between active, passive and semi-passive tag. And most predominantly we use passive tags because of cost. Passive tags is low cost, and depending upon these tags, the range of coverage, the frequency of operation, everything will vary, right? I'll explain that. And when it comes to active tag, it can cover to a greater area, right? A greater distance when compared to passive tags. But passive tags are low cost, so for most of the application, passive tags are preferred, right? And as I said, this reader, that plays a very important role, where the tag can be on any particular device. It can be on one particular device or multiple devices. It can have multiple tags or whatever may be, right? The reader, it will send the signal, it will transmit the signal, and this signal will be received by this tag placed on any particular device, right? And once it receives the signal, the tag gets activated, and in response to this signal, it will transmit the signal. That is, it will transmit the signal with the information which is imprinted on this particular tag, right? So in response to the signal, it will send the information which is present, so that it will modify the signal which is received by them, and it will transmit a different signal. and that signal will be once again received by the reader, and that signal will be sent to the host for further processing. This is the common working. And as I said, we can say this RFID as not a communication device, but it can be called as an interrogated transponder, right? Where you'll have we don't have two separate transmitter or receiver terminals, but it will have a reader and a tag. The reader will send the signal, right? It will activate the tag. It can be an either passive tag or active tag, and then it receives the signal which is sent by the tag, right? And it will interpret that particular signal. So reader's operation plays a very vital role, right? And this tags, right, as I said, it can be active, passive, or semi-passive. It will have the ID it will have its own information. It will have different IDs, right? And as I said, the interrogator is responsible for remotely powering the tag, and it enables the direction of data flow, and then it also performs analog to digital and digital analog conversion. So which means the reader will perform the interrogator operation and the tag will perform as a transponder, right? Just for your understanding, I said, right? And these tags, right, as I said, we have different types of tags, and right now we have sophisticated tags where we have inbuilt sensor system inside the tags itself, and also we have rewritable memory tags. We have a lot of new tags or new technology coming in, so we have a lot of sophisticated tags for this type of applications, right? And this RFID plays vital role in many applications. As I said, very notable applications are aircraft identification. Where in aircraft identification, we can use a radar that will send a transmission beam, right, to identify the aircraft. Where in aircraft you will have a transponder, that is the tag. Say for example, you have a radar here, and you transmit a signal to identify an aircraft. Where in the aircraft you will have a tag, and once it receives the signal, this tag will respond to that particular signal, so that we can identify or we can locate the aircraft or even the army persons, the friend or an enemy, whatever may be, right? And as I said, roadway toll collection, I already explained how roadway toll collection works, right? And we can also use for inventory control, right? Even in toys we can use, and most probably it is used for monitoring or tracking the cattles, and it is used in animal husbandry as well, where the tag can be embedded in the cows, and based upon the information from the reader, we can able to acquire the statistics of milk, right? Like all these things we can be done using this RFID technology. And as I said, it can be an active or passive tags, and this RFID tags does not need, like, it will not have any input signal and output signal. Just it will respond to the signal which is received from the reader, right? And right now, as I said, we have sophisticated tags, and we have different range of applications as well. That is, we have low frequency tags, high frequency tags, and ultra high frequency tags. Depending upon the coverage, depending upon the frequency range, we have a lot of different tags right now, right? If when it comes to low frequency, it will be around 125 kilohertz, 125 kilohertz, where it can cover up to 10 centimeter, whereas in high frequency tags, it is around 13.56 megahertz, and I believe it can cover from 10 centimeter to 1 meter, whereas ultra high frequency, where it covers from 860 megahertz to 960 megahertz, and this covers up to 10 meters, right? We don't want to go depth in about frequency ranges, everything. We just want to know how it works, right? And right now we have a lot of sophistication in it. We have a lot of modified tags. We have advanced sensor systems inbuilt with the tags, right? All those things are available right now. And as I said, you can see the external sensor element, and we can able to rewrite the tags, right? And very important thing is, apart from the operation of the RFID, the reader and tag communication, one thing is very important here. The orientation and the design of RFID tags is very important, right? And the tags has to be designed with proper orientation, right? And it has to address the multi-tag issues as well, right? We will come to that. And as I said, active tags have a greater coverage range than the passive tags. And data rate, right? The transfer of data is also very important in RFID technology. That's because, say for example, if the tag is moving in a relation to the receiver, right? Say for example, if it is placed in the car, as I said, right? The car, you have a gate here, you have a tag here, right? And this information, right? The reader here must get this information. The transfer of data has to be done in real fast manner before the tags move out, right? So only then we can able to collect that information. If not, the information cannot be collected. So data transfer is very, very important, right? And it has to be very fast as well, right? And other design issues includes tag orientation, multi-tag issues, and also privacy, right? When it comes to tag orientation, it is very important that the antennas must be designed in such a way that it should cover the required range as well as the proper orientation along with the reader. And similarly, multi-tag operation, when it is used in multi-tag operation, we have multi-tags very closely related, right? There are chances that the message can collide with each other. So there should be a proper delay time for response. And also it is very important that to maintain privacy, right? So the tags has to be coded so that we can prevent misreading or false informations, right? So this is just the basic information about RFID, just how it works, what are the different ranges, right? What are the different applications, all those things. So today what we have seen is we have seen the working of RFID, radio frequency identification system, right? And I have explained you how it works and what is the applications of RFID. I believe this video will be very useful for you. Thank you, my dear students.